question. Right, so we're going to start off with a vectors question, but a whole week has passed. So allow me to, to refresh your memory on how to deal with vectors. I'm going to do my own question for the time being. Let's say that we have two vectors. I'm going to make up my own question before we try this question. Let's say that you have the vector common p, right? And the examiner tells you that the value of this vector common p is minus 3i plus 5j. And then there's another vector, right? Let me change the color here, right? There's another vector q, and the value of q is 2i plus, let's just call it 4j. And they want us to find the angle in between these two vectors. So the angle might be 30 degrees, 40 degrees, 160 degrees. We just simply don't know. So there is a formula to find the angle in between two vectors. But before I show you how to do that, I want to refresh your memory on how to find something called scalar product. And after, I'm going to show you, refresh your memory on how to find the magnitude of a vector, right? To find the scalar product of two vectors, and you can only find the scalar product between two vectors, all you have to do is take the two vectors that they're talking about. Like if they want you to find the scalar product between P and Q, a dot means scalar product. That's the symbol for scalar product. A dot doesn't get simpler than that. So all you have to do is take the value of P, which is minus 3i plus 5j, put a dot in between. That's the symbol for scalar product. And you put the value for Q after, which is 2i plus 4j. Now, it's very, very important to note that scalar product only works for I and J. For those who come my regular boring math class, right? The letters I and J get special treatment in maths, right? And just to keep in the back of your head, scalar product only works for I and J. So to get the scalar product, all you have to do is take the numbers touching the I, or the items touching the I, and you multiply them, right? You're not actually taking the letter I, so you're just taking the values touching the I's. So you're going to say minus 3 multiplied by 2. So we multiply the I values, then always put a plus sign, and guess what you do after? You multiply the values touching J. Just the values touching it, not the actual J's. So it's positive 5 multiplied by 4. And you just work this out, as simple as that. Minus 3 multiplied by 2 is minus 6, plus 5 by 4 is what? 20. If you work this out, you're going to get positive 14. So that's how you find the scalar product between two vectors. I want everyone to take down this, and then I will show you how to find the magnitude of a vector, right? So take a minute for that, and we'll discuss magnitude. So just to say back again, scalar product is always between two vectors, but magnitude, you could find the magnitude of one vector. The symbol for magnitude is two straight lines bordering the item or the vector that you're trying to find the magnitude of. So if you want to find the magnitude of P, this is the symbol for it. P with two straight lines. That means we're finding the magnitude of P. The magnitude formula only works for I and J, no other two letters. So luckily, P has 3i and 5j. To find the magnitude of a vector, you take the number touching I, which happens to be minus 3, and you square it. Put a plus sign, and guess what? Take the value touching J, which is 5, and square it. And then when you work that out, square root last. Anybody wants to tell me how much is the magnitude of P, right? It's basically Pythagoras theorem, if you didn't realize, right? It is actually Pythagoras theorem. It's not even something resembling Pythagoras theorem. It is actually Pythagoras theorem. Right? You can go to 2 decimal places, right? In how many exam try to go to 2, right? So minus 3 squared, that is 9 plus 25, and you square root that. Make sure you see this on your calculator. 5.83. Right? Remember, work out the underneath part first, write down the value, and then square root it. All right, so as a quick practice, you think you all could find the magnitude of the vector Q? It is following the same format here. Let's see what you guys get. In here. I'm ready, supposed to write the word units after, right? So the answer is 5.83 units, right? I don't have any space to write it, but I'll write it underneath here. It is supposed to write the word units. All right, so answers are coming up. Let me work it out. For Q, the I value is +2 and the J value is +4. So they should be easy. 2 squared plus 4 squared, the I value, J value, add them and square root it. Let's see what we get. 2 squared plus 4 squared, you get 20 and you square root that. Right, 4.47 units. So there must be a reason I am refreshing your memory on how to find scalar product and magnitude. To find the angle in between two vectors, this is the formula. Like if the two vectors are P and Q, this is the formula. Cos theta, theta is the angle between the two vectors, is equal, with the two vectors here what? P and Q. It's P scalar product to Q divided by the magnitude of P multiplied by the magnitude of Q. So let's work this out. We can almost finish this question. P scalar product, PQ scalar product. Remember we got that? The answer was 14. And then we have to divide it by the magnitude of P, which is 5.83, and multiply it by the magnitude of Q, which is 4.47. Work this out for me, right? Take 14 and divide it by this. You'll get a crazy decimal, and then cos inverse the decimal because you want to solve for theta. You don't really care for cos theta. You want theta, which is the angle in between the two vectors. So you all can finish off the question there for me, right? 14 divided by what? 5, that's not 14 divided by 5.83 multiplied by 4.47. Now, I know everybody's going to round off a little bit different, right? I'm running out of space here, so I'm going somewhere here. I'm getting, move that line there. I am getting cos theta is equal to 0.5372. I know different people are going to round it off differently, right? If I go to 0.54, right? That's the 2 decimal places, or I could go, I know some people are going to 3 decimal places. If I go to 4, I will get cos inverse 0.5372. So cos inverse that, second function cosine 0.5372. I'm getting roughly 57 degrees 0.51. Now, everybody's going to get slightly different, but once you get a 57 or 56 or something like that, something real close to 57, take it as correct today. Make sure your calculator is on degrees mode. So A dot B, well, scalar product, right? So just 1 second here, my way. So it's 4i plus 10j dot product 2i plus 5j. Take the I values, multiply them, 4 multiply by 2, plus take the j values, multiply them, 10 by 5. All right, so we're going to get 8 plus 50. It seems that the dot product is what? 58. I think I'm on the correct track so far, the dot product, right? A lot of people are agreeing. To find the magnitude of A, take the I value of A, square it, take the J value, square it, and square root the answer. So 4 squared plus 10 squared, and then you square root that. I'm getting 10.77. And B is how much? Let's B. Oh, 2 and 5. So you say 2 squared plus 5 squared, and you square root that. So anyway, 2 squared plus 5 squared, and you square root that. I'm getting 5.39 or something like that. On the correct track there, guys? Or all my values looking correct? Somebody said. So to find the angle now, remember cos theta is A dot B divided by this, right? So let's see. A dot B, that's the product, is 58 divided by 10.77 multiplied by how much? 5.39. 58 divided by 10.77 multiplied by 5.39. What? How am I getting 0 for this? That makes no sense. Just now, guys. 1, right. Again, 0.99999. Right. So obviously we did no rounding off. We will get how much? 1. Kenya, check it back. When you work this out, you get 0.99999. This is a multiply here, not an addition sign. Oh, I know the mistake a lot of people are making. It's a multiply here, guys, not an addition. It's a multiply. Right? No, put 1, right? When you divide this, you get 0.99999. I think you should round that off to 1, right? Right. Let me explain it back a different way, right? If we had used no rounding off, I guarantee you, if we had used no rounding off, we would have gotten exactly 1. Right? Right. Let's say that we work this out here, right? Remember when we worked this piece out here, it was 4 squared plus 10 squared. So we got 116 square rooted. Let's just say we left it in third form, because third form is obviously more accurate. So if we go over here now, we say 2 squared plus 5 squared. I know you all saw 29 on your calculator. So you can leave it in third form, right? And I think it's a good idea to leave it in third form for these types of questions, right? If you're not too sure how to round off, just leave it in third form. So it will be this: 116 multiplied by the square root of 29. Now, when you work this out on your calculator, you will get exactly 1. Exactly. You won't have to round off. So cos theta is equal to 1. Therefore, theta is cos inverse 1, and it gives you exactly 0 degrees. Right, so new rule for class. Whenever we have the vectors question and we're trying to find the angles in between the two vectors, the magnitude, we will leave it in third form. So that way, we could guarantee that we will get a more accurate answer at the end of the question. So for part B is A dot product B. This is the I value. This is minus 1 here, right? So it's 2 multiplied by minus 1 plus the J values are 8 and minus 4. So it's 8 multiplied by minus 4. So this is minus 2 minus 32. We get in minus 34, right? So I trust everyone has the minus 34. For the magnitude of A, remember for magnitude, we said we're going to leave it in surd form, right? As a new rule in class, so we get a more accurate answer. It's 2 squared plus 8 squared, and we're going to square root it. So 2 squared is 4, 8 squared is 64. We have to square root that. That's 68 square root. Let me know if you've seen any errors, right? Right? Kenya, check it back. B is minus 1 squared. Notice I put the minus 1 in brackets the squared, so your calculator will not give an error. When you're squaring something, especially if it's negative, put it in brackets and then square it. The Casios will give you not a wrong answer. The Casios have a different way of squaring negative numbers. And if you don't put the brackets, you'll get the wrong answer. Plus minus 4 squared, and we're going to square root that. Minus 1 squared is positive 1, and minus 4 squared is still positive 16. So you're going to get the square root of 17. So cos theta is equal to the dot product, which is minus 34, divided by the magnitude of A multiplied by the magnitude of B. Let's see what we get here. Right. We get in minus 1 here by chance. Well, when we divide minus 4 by those surds, we get it minus 1, right? All right. So we're going to cos inverse now. So theta is cos inverse minus 1. Let me check it here. Second function, cosine 1 minus. Yep, the answer is 180 degrees. That's the angle between those two vectors. Oh, no, sir, not yet. Here we have another kinematics question, but the kinematics question has trigonometry in it, right? But this is not the strange trigonometry question I was talking about. It's probably the next question. All right, so I want everyone to get started with this question. Remember, in kinematics, there's three things: displacement, velocity, and acceleration. If you start off with displacement and you want to find the formula for velocity, you have to differentiate once. To get the expression for acceleration, you take the expression for velocity and differentiate it once. And obviously, to reverse the procedure, you integrate, right? So to go upwards, you integrate. All right, so get started. I think I'll be fair. I'm going to give you all 10 minutes to do this entire question, part A, B, and C. Good luck. Easy. Remember, they said the distance, right? Well, and they already mean displacement here, right? It's already supposed to be displacement, right? They made a little mistake there. So X is the displacement formula. So X is equal to 4 sine 3t. Now, before we move on, right, I realize in this question, part B and C were a little too hard, right? I found this question on the internet, and I thought it would have been at CXC level, okay? Forgive me, right? I don't think we'll be doing part B either because it's a little too hard for the CXC level. But part A is definitely on the CXC level, like I'm 100% sure. So they want us to find an expression for the velocity of the particle. If we have the formula for displacement and we want to find the velocity, don't we just have to differentiate? Isn't that all we have to do to find the formula for velocity? So let's differentiate this. X is the displacement and t is time. So let's we're differentiating x and t. So if we differentiate, we will get dx dt, which will give us our velocity. So let's differentiate this. When you differentiate sine, you get what? Positive cosine. You know, but whoever is touching the variable here also goes in front. Now, I know some of you are probably scratching your heads, meaning that you can't remember how to differentiate a trig function. But let me refresh your memory. Let's say you have y is equal to 6 sine 2x. It's easier when it's y and x. Your brain will memorize the y and x. So if you differentiate this, when you differentiate sine, you get what? Positive cosine. And whoever is touching the sine, you put it back as normal. So if it's 2x, you put back the 2x. But whoever is touching the variable here, the variable is x, he will be photocopied to the front. But who is waiting at the front? 6. So when the 2 goes to the front, it will be 2 multiplied by 6 to get what? 12. It's the same format here, but instead of x, it have the letter t. So when you differentiate sine, you will get cosine. Whoever is touching the sine, you put them back as normal. Don't change a thing. Who is touching the variable here? 3. He will get photocopied to the front. So 3 multiplied by 4 is 12. This is your expression for the velocity. Right? Now they want you to find the formula for the acceleration. Well, we have the velocity. Look at it. We have the formula for velocity. To get acceleration, we have to differentiate one more time. So let's differentiate dx dt one more time. So you get dx squared dt squared, but that's really acceleration, as we saw when we differentiate a second time. When you differentiate cosine, you get minus sine. So you're getting minus sine this time. And whoever is touching the cos, put it back. Don't change a thing. Whoever is touching the variable gets photocopied in front. So the 3 will go to the front, photocopied to the front. 3 multiplied by 12 is 36. And don't forget the minus sign here, because when you differentiate cosine, you get minus sine. If you look back in the notes, you will see that formula. This is the answer. All right, so we're not doing part B and part C because upon reading it, I realized it's a little past the CXC level. You won't get something as hard as that. Right, so for those who didn't get all part A, you think this question jogged your memory a little bit on how to differentiate trigonometry functions? Right, so I hope the next question is the strange trigonometry question. This is the one. Right. So I'll put this across here. I want to work out these two for you, right? So in this part A, they want us to solve for theta. All right. What you want to do is throw everybody on the same side. Now, before I do that, right? If you'll remember factorization, like if I have x plus 1 and x minus 2, and this whole thing is equal to 0. You'll remember how you solve for x in normal maths. You just take each pair of brackets and you put it equal to 0 separately. So you will take the first pair of brackets, the x plus 1, put it equal to 0, and if you solve for x, you'll get x is minus 1. So that's your first answer. And then you would take the other brackets, which is x minus 2, also put them equal to 0. And if you solve for x, you'll get positive 2. You will have met this in factorization of quadratics and how to solve the quadratics using the factorization method. But for some reason, If I change up this question slightly, it has confused a few people. For example, if instead of the first brackets, I just have x, and the second brackets, I have x minus 2, and it's equal to 0. For some reason, and I have no idea why, a lot of students shut down because they are accustomed seeing the first brackets with two things, like a x plus something or x minus something. But over here, it just has regular boring x. It's added to nothing and it's not being subtracted or anything like that. But remember, you can pretend this x is also in brackets. So you just put the first bracket equal to 0. So x is equal to 0. There's nothing to solve here. It has already been solved. The value of x is 0. And the other brackets, you put it equal to 0 also, but we know what we'll get here, 2. All right, so I'm hoping that you'll bounce this up at least in regular boring maths. Where am I going with this? This one here, to solve this one, you have to throw across cosine on this side. So you'll get 2 sine theta cos theta minus cosine theta is equal to what? 0. We can obviously factorize here. We can pull out cos theta and cos theta. So let's do that. Let's pull out or factorize out the cos theta. So you'll get 2 sine theta minus 1. Everyone take down up to there. We just factorize out the cos theta. And you see how the cos theta is by himself? At least the sine theta has some friends. He has a 2 and he has a minus 1. But remember what I was saying, right? You just have to pretend he is in brackets. And you have to solve each bracket separately now. So it comes like 2 questions mixed into one. So what you're going to do is take the first bracket, cos theta, and put it equal to 0. Solve for theta and do the same thing for the other brackets. 2 sine theta minus 1 is equal to 0. Now remember, in trigonometry equations, if they give you an equation, when you have to solve for theta, you don't get one answer most of the times, right? In most cases, you'll get at least 2 answers. So I have the little cross here waiting with the quadrants, first quadrant, second, third, and fourth. So go back in your notes and see in which quadrant who is positive and who is not positive and whatnot. Take 5 minutes and send the answers on the chat. Those who can't remember, everybody is positive in the first quadrant. In the second quadrant, only sine is positive. That means everybody else by default is negative. In the third quadrant, only tan is positive. Everyone else is negative. And in the fourth quadrant, only cosine is positive. Right? So whenever you solve an angle alpha, if it lands in the second region, it's always 180 minus alpha. If it lands in the third region, it's 180 plus alpha. If it's in the fourth region, the formula is 360 minus alpha. Question. Remember, 0, when you throw across the cosine, at the point of throwing across the cosine, you get cos inverse 0. But the problem is 0 is not positive and not negative. So you don't know what kind of question it is because 0 is neither positive or negative. Here's my advice. Just pretend 0 is positive. Anytime you're dealing with 0, like the cos inverse, tan inverse, or sine inverse, and you end up with 0, just assume the 0 is positive. So how much is the cos inverse of 0? Let's see. Second function, cosine 0, I'm getting 90 degrees. So we're assuming it's positive, right? So the first answer will be what? 90 degrees. Where else is cosine positive? Cosine is positive in the fourth region. So remember, we're pretending the alpha is 90 degrees, right? The first answer you always get is always alpha. Always, always, always. Right? I think you call this the basic angle. If it lands in the fourth region, 360 minus 90 is 270. So your two answers, well, for the first part of the question, your two answers is 90 and 270, right? So I just saying it back again just in case. Anytime you're dealing with zero, assume it's positive, and that will make your life easier, right? Believe me, if you had assumed zero was negative, you'd end up with the same exact two answers. Take my word for it, you would have gotten the same exact answers. Let's try the other one now, right? Throw across -1, you're going to get +1, right? So you're getting sine inverse, sorry, 2 sine theta is equal to +1. The 2 is a multiply, throw it across, you get a divide. So you end up with the sine inverse of how much? Theta is the sine inverse of 0.5, which I know is 30 degrees. Now, when you're sine inversing it, at this point in the question, it was a positive type of question. So the first answer is 30 degrees. Where else is sine positive? In the second quadrant. So it's 180 minus 30, right? 180 minus 30 is 150. A lot of people got the second equation correct. The first equation, almost everyone forgot the second answer, the 270. Right? This is a real popular question in the exam, by the way, and this particular question. So that's why I wanted to make sure and work it out for you. Clear up a few things here. All right. So, oh, by the way, they removed functions of the ADMAT syllabus. So things like fx and gx, and to find the inverse of a function or find the function fg. That was removed a couple years ago. You will only find that on a regular boring math syllabus. Okay. All right. So now for this question, right? You all remember this formula. Tan theta is equal to sine theta divided by cosine theta. I believe they give you this on the formula sheet, which basically means anywhere in maths, if you see tan theta, you could throw away tan theta if you wish, and replace it with sine divided by cos theta. Right. Which is what you need to do for this question, I believe, because you have a tan theta here. Let's get rid of that tan theta. So we have sine theta is equal to 2. Let's throw away Mr. Tan theta here and replace him with sine theta divided by cosine theta. And what we could do here, and we could cross multiply. So let's do some cross multiplication. 2 sine theta by 1 is 2 sine theta is equal to sine theta multiplied by what? Cosine theta. You all realize that this question and this question really resemble now? And you can throw this across on this side, and you will get 2 sine theta minus, remember this whole thing is positive, right? This whole thing is positive. You'll get minus sine theta cosine theta is equal to 0. And what you could factorize out now, you could factorize out the sine theta because both of them have a sine theta. So you pull out the sine theta and you will get 2 minus cos theta is equal to 0. And remember, this minus cos theta is really minus 1 cos theta. You think you're going to solve this equation for me? This sine theta, just put it in brackets. Put him equal to 0 and put him equal to 0 and get 2 answers for him and 2 answers for him. Good luck. This question. I need to clear the screen. I need some space to, work out here. So it was, if I'm not mistaken, it was sine theta 2 minus 1 cos theta. This is equal to 0. So for the first one, right, you put in sine theta equal to 0. So your sine inverse, so you get theta is what? Sine inverse 0. Now remember, when it's 0, I said that you can assume it's positive, right? So sine inverse 0 will give you what? will give you 0. So the first answer is 0 degrees. But remember, sine is positive. Everyone is positive here. And only sine is positive here, right? In this region is 180 minus alpha, and this one is alpha. So when you go to this region now, because this is where sine is positive, and we assuming 0 is positive, we pretending this is how much? 0. So 180 minus 0 is 180. Everyone got the first part correct, I assume, right? I'm looking through the answers here. It seems to be correct. The second one, a lot of people are saying it's given some problems. Let's see what problems we get in with this. So the second pair of brackets is 2 minus 1 cos theta is equal to what? 0. This is positive 2. You throw across positive 2, you get what? Minus 2. So you get minus 1 cos theta is equal to minus 2. Remember, you throw across the positive 2 first, eh? Minus 1 is a multiply. Throw it across, you get a divide. So cos theta is equal to positive 2 because you divide 2 minus. Right, so you get the cos inverse of 2. Anyone getting an error on your calculator? You're supposed to get an error. The second one has no solutions, and that happens a lot in the CXC exams, right? It's not a mistake they made. The first one gives you solutions, but the second one has no solutions. So you can put error, or you could say, well, the better thing is to put no solutions. You can write out the word no solutions. Right, and that could happen in the exam. It's very, very popular. Right, so take a 20. I want everyone to write down this one completely as well. So take 2 minutes. All right, so this one is that's on a gradient of a curve. So this is it's either a differentiation question or an integration question. I'm not going to give it away as yet. Good luck. I'll give you 5 minutes. Okay. Remember they said the gradient, right? Whenever you hear the word gradient, remember dy dx is the same exact thing as gradient. So they're already trying to say dy dx is equal to this expression, 3 minus a half and whatever square root x here. So if you want back the original equation, the one with y, you need to integrate, because anytime you integrate dy dx, you will get what? Y. But when you integrate it, you will get an expression plus c. Now, also, it's not a good idea to integrate if the x is underneath, right? It's really, really, really not a good idea. So this half, that was square root, sorry. The square root is the same thing as to the power what? A half. So what you could do is throw this on top now, but the 2 remains underneath. And when you throw in the x, you throw in the x alone on top. So when you throw that on top, you get 3 minus a half. Well, the x goes on top now, right? I'm not writing it kind of bad here, that's not. The power becomes minus a half here, and it's a 2 on the underneath. So this is the expression you want to integrate now, because when you're integrating is what the x on top, right? So guys, integrate this and you will get the expression for y, but remember, you will get a plus c. You need to solve for c. Good luck. All right, so we replace, well, using this over here. So y is 3. 3 by 1 is 3. 1 to the power half. Well, 1 to the power anything is, well, 1, right? Yeah, well, this is normal math stuff here. Yeah, you're getting c as 1. Right, so for the final equation, you're just replacing the c with 1. Right, so this could be a final answer for the examiner. So, not seeing any mistakes, so let's get going, right? Let's do one more question, all right? We still have time to do one more question. All right, so let's see what the next question is about. I believe it's a volume question, right? See if you can go back in the notes and see if you can find the formula on how to find the volume of a graph, right? Now, this is 5x squared. I know the square kind of hard to see here, so I'll put it in. About 5 minutes. But the formula to find the volume is pi integral. Well, you're integrating between 0 and 3. They said it here. But you have to square this equation. So it's y squared. So it's supposed to be 5x squared plus 2 squared. That is what you are integrating. So square doesn't mean you're going to square everybody in the brackets. Remember, that's a trick, right? Squared means you have to multiply it by what? Itself, right? So you have to expand all these brackets first, simplify it, and then integrate. Right? So it's a long-ish question. Right? So instead of about 2 minutes before I jump in again. Right? So when you expand out these brackets, I think you will get 25x to the power 4 plus 2 by 5, 10. And you'll get 20x squared plus 4. How much people got that? Well, when they expanded out the brackets. Right. So a lot of people are getting it. Right. So you integrate this now. Now, I think they made one of the values look terrible here, this x squared here, but the 25, you're going to add 1 to the power and then divide by the new power. So it's 25x to the power 5 divided by 5. That's good because 25 divided by 5, well, it's 5, so that works out good. You add 1 to this power, so you're going to get 3, unfortunately. Then you divide by 3. I hate it when it ends up being divided by 3. Integrate 4, you're going to get 4x, right? You have your big square brackets here. You're going to have your 3 and your 0. 25 divided by 5. Let me just simplify that one time and put what? 5. Now, the good news is, well, when you're substituting a 0, remember, everybody has an x here. So when you're substituting 0, the second part going to boil down to 0. It's just the 3, really, you have to work out, right? So in the exam, you have to show them that you work out the 0 too, unfortunately. So you're going to look like this. 5, 3 to the power 5 plus 20, 3 to the power 3 divided by 3 plus 4, 3. That's the first part minus the second part. Yeah, you have to show them the 0. Even though it's going to boil down to 0, unfortunately. Right, so work this out, guys, and tell me. This is the last question with you. Don't worry. I can sense the tiredness in the class. Right? Right. How's Spanish orals going, guys? You all get anybody had the Spanish orals as when I work this out, I get it 1407 here, and this part is 0. So obviously the final answer will be 1407 units cubed. And we have to multiply by the pi weighted on the outside. I can't believe I forgot that. All right. It's pi, yes. We have a pi weighted on the outside. Thank you for the person who reminded me.